So I'm Jonathan Donaldson. I lead the software-defined infrastructure group at Intel. And you probably have been seeing our logo around these types of events fairly significantly in the past couple of years. And so I kind of want to walk through that a little bit here, but let's have a show of hands, right? A little bit interactive start to this. How many of you use Intel CPUs in your data center? That's always a good one. And you don't. I'm just kidding. But the flip side of this is how many of you use Intel software? How many of you know Intel is a software development house? Okay, a few of you. That's great, actually more than I expected. If you actually took about the 5,000 developers that we have on staff that we use in things like Linux, and things like ChromeOS, and things like CoreOS, Tectonic, etcd, we would probably be one of the largest software development houses in the world. We have about 5,000 developers and support staff that we use for this type of projects. So with that, I kind of want to walk through a little bit about why is that. So why are we at Intel, and all of us here, so passionate about data centers and cloud technology? And one of the problems that I've always had in the past, and we actually created hopefully a funny little video for this, is explaining to my wife and my family what I do for a living. And so everybody was saying, so you do computers, right? And so we said, well, it's more than that, right? The data center is actually a lot more than that. It actually is core to everything that you do in your modern world. And so we kind of made this funny little video about that to kind of set the stage for why this is so important to us. Please roll the video.
Hey, see, I don't think I can pull off a mustache.
Hey, where you been?
Oh, you found us.
I can't stay though.
What?
What do you mean you can't stay?
You just got here.
I know. I'm meeting somebody.
Oh, do tell.
I don't know. It's a blind date.
Well, she'd have to be, right?
Where are you taking her?
It's called Lay something or other. It's in my phone.
Answer me this. If you don't know what she looks like, how are you going to find her?
She's going to be wearing a red scarf.
Oh, he's thought of everything.
Covered.
Very smart.
All right, I'm out of here.
All right,
Okay.
well, you call if you need anything.
Thanks. Thanks for the drink. Hey, buddy.
Hey!
Sorry.
Hey, buddy. Where are you headed?
Just give me a second. I'm going to look up the address.
Where are we going, huh?
Sorry, man.
I can't drive around like this all night.
It's the same thing as your screen, man. Data center not available. I don't know what.
End of the tour, boss.
Oh my God, where's my wallet? I promise you I'm good for it. I'm really sorry. I just need to look something up, please. I just need to look it up real quick. I need to find this. I'm out. I'm sorry. Hey, lady, I'm so sorry. Have a great night. Sorry, you got really good rhythm. Why are you doing this to me? What have I done?
Can I help you?
You can't because
No?
I'm here.
No, you know what? I can't let you in, right?
Excuse me?
Well, this isn't that kind of establishment. How's it going, man? Good to see you.
Well, what kind of establishment is that? You're letting that guy in?
Yeah,
What's going?
this kind of establishment.
No, you can't do that to me. You have no idea. No, sir.
the most amazing thing about that video is my wife said, oh, okay, I get it. I see the stuff that you guys do. You're still a nerd, but I now understand it. So data centers are core to everything that we do. The cloud is core to everything that we do in our modern life. So there are many different types of clouds, right? And a lot of it depends upon where you start from. Alex had talked about Giphy. When you let engineers name things, they don't come up with very good names. So we call that cloud type B, whereas the Azure and the AWS and the vCloud Air kind of side of things are what we call cloud type A. It all depends upon where you start from. If you started from servers to virtual machines and you like that kind of a concept of core root access to something and being able to go and hug the blinky lights, that's the kind of the cloud type A. If you started from things like search or SaaS, right, where you have a set of applications that you've broken up into microservices and therefore into containers, that's when you start to get into things like Cloud Type B, which is obviously the Giphy or the Google style of things, Facebook, Twitter, Airbnb, and so forth. And so we think that this is a very interesting dynamic between the two. We are starting to see the merger of Cloud Type A and Cloud Type B over time. And so you will see Intel investing a lot in each of these types of scenarios and helping to pull them together over time. So the bigger answer is what kind of cloud are you going to have and why? So one of the things I really want to do is kind of talk to you a little bit about why are you here? And then why are we here, we being Intel? So we talk to a lot of customers. Obviously, a lot of people raise their hands. We have a lot of customers out there. And one of the things that we started to look at is, okay, so what happens to the dynamic inside an enterprise when you start to turn on these type of things? As you go from the traditional kind of starting point where data centers are for the most part today, and you drift over into the virtualized cloud, the cloud type A side, and then as you get kind of into the cloud type B, what does it really do from a TCO perspective? And so you can see that as you get into the cloud type A perspective, I have virtual machines, they're automated, they're orchestrated to some extent. You really kind of get a really good return on that, 25, 30%, give or take. But really, once you get into the Giphy style of development, deployment, operations, and management, and automation in your data center, you get a tremendous change in your TCO, about 66%, give or take. And so the idea here is that if you can get your internal IT developed and deployed in this style, right, there's a tremendous amount of benefit from a cost of operations. Not only that, agility is key. Right? So agility is incredibly strategic in today's modern world, right? So being able to roll out new services, right? New mobile applications, new kind of business revenue generating ideas, right? Having the ability to take something from the napkin and the bar, right, into full production in a very, very short period of time with a very, very low barrier of entry is incredibly powerful. And so we kind of have seen this transition, right, between the traditional and then we got the virtualized, and now it's the cloud-ish, right? So most IT out there that have deployed kind of that cloud type A, we kind of say they're the cloud-ish, right? So until we get utilization across data centers up and above the 70% range, until we get the time to deploy services from the under 3 hours, which is kind of what they tag from an industry perspective, to continuous, right? That's when we really start to see those major benefits. So hopefully, there's a bit of an understanding through kind of those couple slides and the fun video is like, why are you here, right? You're here to help your business run as efficiently as possible, for IT to be a strategic portion of the business and be able to do that in the same style as the big cloud players. Why are we here from an Intel perspective, right? So, it used to be there was two types of clouds. We talked about that before. There was the fast movers, right? The tier ones, right? We call them the Super 7 now. That's the Amazon, Google, Facebook, Tencent, Alibaba, Baidu. Those are the big players in the cloud service provider space. And they grow at about 45% year over year from our volume perspective. And then if you look at the tier twos, which is the Apples and one-on-ones and Box and Twitter and so on and so forth, we kind of consider those tier twos and they're growing at almost the same pace. But the more interesting portion of that is actually the private cloud side, which is growing, it's a lot of small numbers at this point, but it is a very, very significant growth. And so what this means from an Intel perspective is that when our customers start to get seriously interested in a technology space, we're along for the ride, right? They come and ask us, how can you help us get to where we need to be, right? You are our provider for this technology, and how can you help us get there? And so when our customers get interested, and we're in the game too. So what are they telling us? Wow, we'd really, really like to go do what we're seeing those major cloud providers do. We would love to have Giphy, but we can't. It's complex, it's difficult. I don't have PhDs rattling around in the hallways to help me with that. And so how do we do that, right? There's still gaps that remain. What do I choose? It's too complex, and there's key features that are missing. And so those are the things that Intel, typically from a software perspective and from an investment perspective, comes in and starts to help with. The other reason that we are so interested in this, right, it's not all altruism, is that there's this thing called Jevons Paradox. And we actually kind of stumbled upon this concept because in the virtualization days at Intel, right, when the first virtualization and hypervisors came out, right, there was a little bit of the sky is falling. People were running around the hallways going, oh my God, people will buy, if they can now put 10 servers on one server, they're going to buy, 10 times less equipment. But the actual opposite was true. And so we did a bunch of research internally, and we found this thing called Jevons Paradox, which is he's a 19th century economist who doesn't look really happy, but if I didn't told you that, you'd probably thought it was Redbeard, wouldn't you? Before the latest growth. And so what Jevons Paradox is, Jevons is a 19th century economist. He did a study on coal, and what he found is that as you make the efficiency of something significantly better than what it was before, and thereby lowering the unit cost, right? When you combine that with an ease of access, right? I can get those resources easily. This amazing thing happens, right? And here's the paradox part. Because normally you would think if I make something a lot more efficient, people will use less of it, right? Or they will just use the same amount that they were, but because it's more efficient, the net volume would be less. But it's actually the opposite. You get this wave of innovation that happens, and this, for us, this wave of consumption of these resources and therefore more sales. And so it's not all altruism, but it is a win-win situation for everybody. So I'll give you an example of this. So if we were a couple of people sitting in a bar and we didn't want to go outside in the rain to catch a cab, or we didn't have cash in our pocket, we would be kind of stuck typically a few years ago. But if we had this brilliant idea that, hey, what if we did like a ride-sharing kind of service thing? How do we get that started, right? So before the Giphy style of delivery, right, and before the advent of ease of use and ease of access for these types of low-cost resources, the barrier to going and trying out that idea would be incredibly high. But because, with a swipe of a credit card and a little bit of development time, right, we can go try ideas. And oh, by the way, when we try that idea, if it fails, that's okay. We're out, $50 or something like that, and a little bit of time. If it's successful, it scales with us, right? Because if you would have done it the old way, and you said, okay, I'm going to go grab some colo space, I'm going to either lease or I'm going to buy some servers, I'll get them in there, I'll put the OS on there, I'll do all this heavy lifting myself. The experience for the first 100 people that came in while you're testing it out might have been great. But again, if we're looking back, 10 years, if we had gotten slash-dotted at the time, and we had 10,000 people coming in and trying our service, the first 100 would have gotten a great experience. The next 9,900 of them would have had a terrible experience, and they would have never come back. And like the adage says, if you don't have something nice to say it on Twitter. They would have told all of their friends, and then your business would collapse. But with the advent of these types of cloud technologies, the Giphy style of delivery, the ease of access, right, now it scales with you. So if your business is successful, all 10,000, 15,000, 100,000, million, so on and so forth, users will have the same consistently good experience with your application because it will scale with you. So that for us is, the non-altruistic win-win situation if we can get this movement actually moving forward significantly. And as you saw in the previous slide, this isn't just words. Each one of these places is where this is happening, and you can see the growth in those spaces. So it's proven out. Wow, my fonts got really messed up there. So we have launched an external representation of this work called Intel Cloud for All. The goal is to unleash tens of thousands of new clouds. We think that while the industry is moving, and you would say, oh, that 45, 44, 75%, those are really good growth rates. We think it's moving too slow. And so we are going to invest in a lot of things. Some of those we've announced already. We're going to optimize a lot more things, and I'll talk about a few of those. And we're going to help align the industry. You heard about the CNCF today, or a portion of that. Standards, right? APIs. Those things are what really drive the innovation forward. So quickly on what this looks like from the perspective of Cloud for All. We have announced quite a few collaborations, both from an investment perspective, and an optimization perspective, and from an alignment perspective. We have partners with Mirantis and Red Hat and CoreOS, with Tectonic and Mesosphere, Docker, Redap, Microsoft, you name it, right? So there probably aren't many companies out there that have as much contact with your data center, operating system vendors and application vendors as Intel. And so we've been working with all of them to kind of make this dream a reality. And we've been working with Alex and CoreOS quite significantly for a while. And we love what they're doing, and we want to see and help it move forward. So let's get into probably a little bit more of the fun part. Right? So hopefully at this point we said, okay, here's why we're here, here's why you're here. But what are some of the things that we're actually doing, right? So we can geek out slightly. Optimization, right? So this is one of the things that Intel does really, really well. And so we are looking across the landscape here at what can we do to help our customers, right? To make them more efficient, to kick off that first portion of Jevons Paradox. So we're focusing on things like performance, scalability, security, making it more reliable for your applications, and most importantly, driving the ease of operations, ease of use, ease of consumption, right? It should be easy for you to use. First thing, Go. The Go language, kicked out by Google, thank you guys, is one of the up-and-coming languages, if not the up-and-coming language next to Python, for infrastructure service creation. And so we took a spin at it, right? Intel is incredibly good. We have lots of propeller heads in the back room that do this for a living. And so what they did is they took a great first pass on this, and we have driven the performance of Go in the latest release up to 200% better than what it was before. And this was a couple of guys just taking a look at it, and this is for memory operations. And so the next step is we're going to dedicate a whole team to go and optimize, Go. Container security. One of the big things that we heard from many of our customers is, I really love the container concept, but the problem that I have with that is that I use virtual machines. I have a multi-tenant environment. How do I go have the same level of security? We care about security just as much as Alex does. How do we have the same level of security in our container environment? So we went and spent a bunch of time and attached the same technologies that happen in the silicon on VMs to containers. So we've done the VT attach, the virtual technology attach from x86 architecture into containers. And so now containers are as secure or better than virtual machines. etcd. Again, this is one of our performance engineers spent a few minutes looking at etcd, and probably a few more than a few minutes. But he kind of really did just a first pass on some optimizations on it, and we've hit 15% or more optimization against etcd, as well as making it more reliable at scale. And this was just, literally just about an hour's worth of work or so. I'm sorry if it was more than that, but for marketing purposes, I'm going to say an hour. So the next step is Nick Weaver and his team, as well as our legions of developers, are going to go look at etcd, much like we're looking at Go, and help drive a tremendous amount of optimization in there. Now, the net outcome of this is things like Tectonic, Kubernetes, Giphy will be much, much better than they were before. They will be more optimized, more efficient. We will kick off that wave of Jevons Paradox. We will drop your TCO. This is what we do. This is what Intel does behind the scenes for all of our customers and all of our partners. And today, it's the day of introductions. we are introducing something called Snap, which I am incredibly excited about. We've had a team internally, kind of on a skunkworks project, put this together and kick it out. One of the things that we found is that it is incredibly hard to see what's actually happening on the processor unless you are a processor person. And there's a ton of different agents out there that can collect little bits of information, little bits and pieces, but none of them can collect everything, and none of them, kind of have the abilities to go do the things that we've put together in Snap. So what Snap is an open source telemetry framework that we are releasing today. If you go to the GitHub URL, and it is absolutely amazing. Nick's team has done a fantastic job on this. And so what they've done is they've created an agent to rule them all. And what this agent will do is it can collect against pretty much anything that we have available in the CPU. It can also collect from anywhere else, right? It's a framework. You can create plugins underneath, right, to go collect from different places. You can collect from CollectD if you want to. You can collect from libvirt. You can collect from the silicon itself. Then you can, through the same framework, do transformations, right? So you can chain together individual pieces. So you might say, okay, I'm going to normalize this data, and I only want the deltas. And then I'm going to throw it through an encryptor, right, with my key, and then I will then actually transmit it either pub/sub or whatever. The nice thing is that, again, that framework on the top, with just a dozen or so lines of code, you can change how it publishes to and who it publishes to, and you can actually do multiple subscribers. You can go message bus. You can go straight to, if you're a Science Logic person, you can create a Science Logic plugin. If you're a Zabbix person, you can create a Zabbix plugin, et cetera, et cetera. So the very, very interesting thing about this is we've actually kind of created a framework and a couple of sample things, and we've actually proven it out, right? So once you actually start to get some visibility into what's happening on the CPU, you can do some very, very interesting things as far as bin packing, and more condensed containers, et cetera, and really find out about the performance of your application. And so we're really excited about the opportunities that Snap is going to provide. We invite you all to download it, try it out, kick the tires, let us know, join the community. We'd really like to see this thing be a good part of what's driving Giphy. And then finally, to some extent, right, making this easy to consume, right? So again, we've talked about our main goal with the Cloud for All initiative is investing in the community, right? Optimizing portions of the community where we can, right, to make that first portion of Jevons Paradox happen. And then finally, right, the ease of use, ease of consumption is very, very important to us. And so, much like Alex had mentioned before, making it easy for you to leverage and use Tectonic. We've worked with the CoreOS team and Supermicro, along with our friends at Redapt, to go build what we call reference architecture and a skewable, purchasable appliance, if you will, for Tectonic, so that you can have not only an easy way of doing this, but the trusted configurations, the most optimal configurations for trying this out in your environment. And so we invite you, if you are interested in deploying this, give this a look. This is a great, easy way to get started. So again, engage with us if you can, right? Download the reference architectures. Go take a look at Snap. Help us, let us know what else we should be working on, what other areas you'd like to see optimizations done, or what other areas would be valuable to you as our customers to have ease of access to a technology. Collaborate with us, right? If you want to try this out, let me know, right? We can work out proof of concepts along with CoreOS for Tectonic and Supermicro, trials of that. And then more importantly, right, if we really want to get Giphy moving, if we really want to have things like the CNCF, the Cloud Native Foundation, and containers really take off and be the next wave of delivery for enterprise IT, advocate with us. Help us, right? Tell us what you need, but more importantly, tell 3 of your friends that you've tried it, how much it's changed your environment, the strategic benefits, et cetera, et cetera. So that's what we're asking for today. But most importantly, thank you for the time today. Thank you for being our customers, and thank you for the innovation that everybody keeps driving.